another rates of change video. So he's asking about the rising of water. This means he's asking me to find simply to find the dH to dt, the rising according to time, right? So we have to find dH over dt. What is dH over dt? dH over dt will be equal dv to dt over dv dH. What is dv dt? dv dt, first let me substitute dv dh. dv dh, I found it, pi h into 24 minus h, and that's it. What is dv dt, right? And what is dv dt? Simply we have it. Do we have it? Let's see. At the beginning we said, that's it. At the beginning we said the water is poured in a rate 5 inches cube per second. And what is that? This is dv by dt. Seconds is for time and inch cube is for volume. So it's volume over time. This means it's 5. So this is 5. And what else we have? He said he wants this volume of water, right? This rising in water. This means the h to dt according to h becomes 2 inches. So we can substitute instead of h2 also, that will be 5 over 2 pi times 24 minus 2. It's 22. So my final answer will be the h2 dt is equal to 5 over 44 pi. This is the final answer. If we want to divide it, we can. And we have a final answer in decimal. So it's 5 divided by 44 times pi times 3.14, and the final answer will be 138.16. No, it's 0. Yes, it's 0.0361. 0.0361, right? Approximately 0.036. It's height, so it's inches per time, seconds, right? It's inch per second. This is part A. Let's go to part B and check. What do we have? In part B, he said express the area of the top surface of water. Express the area of top surface of water. Top surface of water is what? Circular, right? Top surface of water takes the shape of the container and its hemisphere, so it takes the shape of circle. We need to find in part B the area of the top circle of top surface of water in terms of h, and deduce the rate at which this area increasing when h equal to inches deep. So we have to find the area and deduce the rate in terms of h, right? The area in terms of h, and we deduce the rate at which this area increases. Rate which area increases when h is 2 inches deep, right? All right, let's start. First, area. First, what is the area? What is the area of a circle? It's pi r square. That's great. And what is r square? Let me go back to the figure. Let's go back to the figure. R square, I mean by r the radius of the circle. This is r, right? This is r. That's nice. All right. So if we want to find this radius, simply I need to have this first. How much is that? Okay, my figure is not correct. This is the center of the circle, right? So this is the bottom exactly of the hemisphere. Okay, how much is that? It's from the center to the hemisphere. This means it's 12. And how much is this? This is height. Okay, so how much is this value over here? It's 12 minus height, and this is r. And how much is that? This is 12 too, right? So 12 hypotenuse, r radius, 12 is hypotenuse. This hypotenuse here is 12. This r is the radius of the circle, small r, and this is, it's simply, this one is simply, is 12 without height, right? Minus height, 12 minus h. So we can do Pythagorean here. We can tell him that radius square plus 12 minus h all square, right, is equal to 12 square. So I need to find radius square in terms of height. So radius square is equal y in terms of height, because he wants me to find the area in terms of height. So this will be equal 144 for 12 square, and this goes to the other side and we expand it, so it will be minus 144 minus 2 times 12 24 times h minus 24h times minus plus 24h, because we're moving it from place to place, from side to side, plus h squared. This means it's minus h squared. 144 minus 144, we simplify them, cancel, 0. What left is h into 24 minus h, correct? So this area will be simply pi h into 24 minus h, or pi 24 pi h minus pi h squared, right? So what do we have here now? We need to find dA to dH. This is the area in terms of h. Now I need to find the rate, deduce the rate, right? dA to dH. Deduce what he said in the question. Let me check back. Deduce the rate at which this area increases with height, right? So the A to the H is equal to what? It's derivative of area in terms of this height. What this will be equals to 24 pi minus 2 pi h, right? This is the A to the H. Okay, what else we can do? We need to have the A to dt. The A to dt is equal to dA dH is equal to dA dH times dH dt, right? I need to find dH dt, height in terms of time. dH dt is equal dA dt over dA dH, right? dH dt is equal this. And simply, or no, I'm not, what I'm doing, I'm finding the area, the A to the time, right? The A to the time. This is wrong. All right, back. I'm finding the A dt, and I have them all. I don't know what I did. I have the ADH, we have it. It's 24 pi minus 2 pi h, right? And times the h dt. The h dt, we found it in the previous part, which is 5 over 44 pi. So it's 5 over 44 pi. And he said when h is what? When h is 2. So we have to put 2 instead of h. This will be 24 pi minus 4 pi multiplied with 5 over 44 pi. This means it's 20 pi times 5 over 44 pi. Pi cancel. 20 times 5 is 100. 100 divided by 44. So the final answer for the A to dt, increase in area, right, of the circle, is equal to, let's divide by 5, by 4, it will be 25 over 11, and since it's area, so it's in inches square per second. He wants me to find the area of the circle, the rising of h, right, in terms of rising of h. It will be like 25 over 11 inches square per second.